Hey there, mateys. We are going to jump right into 1.1. It's all about powers and exponents. Before we begin, I first want to emphasize that everything I'm showing you is available on Big Ideas. If you click on Dynamic Classroom, it will bring all of this up. There's a lot to explore. I'm going to go kind of quickly just to keep this video relatively short. I believe that exponents are review for you. If not, then you might want to rewatch this video, pause it when you need to, slow it down a bit. The first thing is some vocabulary. So when you see the word power or exponent, usually in math, those are pretty interchangeable. There is a slight difference though. So the three words you're going to see a lot here are power, base, and exponent. So if you have something like 3 and this little 4 up here, the 3 is called the base. That's like the base number. The 4, the little tiny 4 to the upper right, that's called the exponent. 3 to the 4th altogether is a power. It's called 3 to the 4th power. And what it means is you're doing 3 times 3 times 3 times 3. There's 4 3s all being multiplied together. So 3 to the 4th power is 81, because that's what 3 times 3 times 3 times 3 is. If you have something to the second power, you could say, like this example here, 3 to the second power. You could say 3 to the second power. It's normally just said 3 squared. 3 to the third power, you normally say 3 cubed. 3 to the 4th power is just 3 to the 4th power, 3 to the 5th, 3 to the 5th, and so on. So that is kind of a brief, quick overview of powers, bases, exponents, vocabulary. Again, if you need to pause the video, take some notes, make sure you understand this, I would highly recommend that. Now we're going to do some examples. So example 1. These ones we're just going to walk through so you understand them, and then I'm going to have you do some on your own. So if you have 7 times 7 times 7 times 7 times 7, you could write that as 7 to the 5th power, because there's 5 7s that are all being multiplied together. If you have 12 times 12 times 12, that's 12 cubed, or 12 to the 3rd power, because there are 3 12s all being multiplied. That answer is not 36, by the way. It's a very big number. And then this last example here, 100 times 100 times 100 times 100 times 100 times 100. You would write that as 100 to the 6th power, because there's 6 hundreds all being multiplied together. All right, now it's your turn. Okay, so I want you to try writing 6 times 6 times 6 times 6 as a power. Okay, if you said 6 to the 4th power, you're right. Well done, because there's 4 6s all being multiplied together. Okay, what about this next one, B? Okay, if you said 14 to the 5th power, you are correct. And what about this third one? All right, that last one is 50 to the 3rd power, or 50 cubed, because it's 50 times 50 times 50. There's 3 of them. There you go. Hopefully this has been easy so far. Okay, our next set is actually to, I think, evaluate some of these. Oh, yes. So example 2 is finding the value of powers. Some of these numbers are going to be big, so you're going to want some scratch paper. For a lot of what we're going to do on this specific chapter, it's okay to use a calculator because these numbers get big real fast. So if it says to find the value or evaluate 7 squared, that would be 49 because it means 7 times 7. If you have 5 to the 3rd or 5 cubed, that is 125 because it means 5 times 5, which is 25, times another 5, which is 125. Okay, a common mistake if you're doing 5 cubed is to do 5 times 3. That's not what it means, so don't make that mistake. Of course you won't. And now is your chance to prove it. Okay, using scratch paper, maybe even a calculator if you need to, I want you to evaluate 8 cubed. Okay, if you said 512, you are correct, because 8 times 8 is 64, and then 64 times another 8 is 512. Okay, what about this one, 13 squared? All right, 13 times 13 is 169, so hopefully you said that. Okay, moving on. And again, if this is going too fast or you need to rewatch the video, feel free to rewatch the video. If you have questions, write down your questions so you can ask me in class the next time we have class. Okay, the last bit of vocab is called a perfect square. So the square of a whole number is a perfect square. So 64 is a perfect square because 8 times itself, or 8 squared, is 64. That's why 64 is a perfect square, because 8 times itself is 64. 20, however, is not a perfect square Because, for example, 4 times 4 times itself is 16. 5 times 5 is 25. So 16 and 25 are perfect squares, but 20 is not. There's no same number you can multiply by itself and get 20. Okay, this is one that you might want to reread, look at these examples again before you try these stepped out examples. But here we go. Okay, so determine if 50 is a perfect square. Okay, it is not a perfect square. So 7 times 7, 7 squared is close to 50. It's 49, but that's not 50. Okay, what about 9? Is 9 a perfect square? 9 is a perfect square because 3 times 3 is 9. There is a number you can multiply by itself to get 9. Okay, perfect squares have been very confusing for some 6th graders in the past. If you're not sure about these, you got to ask for help, get some help on these. In class, we're going to be working through problems. And if you need help on perfect squares or any of this, make sure to ask. And the last example that we're going to do is how to use these in real life. So you can use powers to find areas of squares, and that's why squares are called squares. The area of a square is equal to its side length squared. So like here, if you have a side length of 3, and this is a square, then the area is 3 squared, or 3 times 3, which is 9 square units. Okay, so if it's a square, you just multiply the side by itself, and that's the area. All right, so here we have a Monopoly board. An actual life-size Monopoly board, they make these so people can like play Monopoly like as people on a big board. And the length of the board is 11 yards, and it's a big square. So it's an 11 by 11 square. So the area of the board is 11 squared, 11 times 11, which is 121 square units, or square yards. Okay, so now your example, good luck on this one. A baseball diamond is a square with a side length of 90 feet. What is the area of the baseball diamond? All right, so this one is 90 squared, and 90 times 90 is 8,100 square feet. And just a reminder, area is always square units. All right, so that's it for our Ed puzzle. Woo! If you need to rewatch it, take some notes. I would highly recommend it. When you come to class next, we're going to work through problems for 1.1, and I'll be in class to help you out. So will your classmates. All right, good luck, Pirates. I'll see you in class. Arr!